are multiple sensors, omnidirectional, they have touch screen, they have expression field LEDs, they have RGB cameras, and what we did was to use them for other things after the project finished. The project was Monarch in FP7. And right now, one of them is being used by the team for the competitions. It has an arm, not today, but usually it has an arm. Another one, and that's what I was telling you, another interesting part of doing. Because one of the things that came over, where is over there. These guys are quite good. They used to win RoboCup at home, and this time he decided to come along. He did not like this team. And so he told us, well, because I'm coming along, I cannot transport the robot in luggage. Why don't I run my code in your robot? So the Homer team is also a robot like the other one, which is a soft robot Homer. And so these robots in action in the field. And so it's nice because we can really run different softwares. The robot is really being ready for that. And this week, effectively, we have 3 different ones running, and that's nice to see. It's not so usual. Just want to show you quickly. There's something else there to show you. Because these are things we do not show you. Of course, there's another one here. Sorry, I left it. Okay. Okay, let's forget about this one. Okay, so here, another thing we do, and it actually is a nice continuation of what you were watching in the previous lab, because we have some quadcopter stuff, but as I said, in our case with multiple robots, well, 2, we want to go more, but for now it's 2. Anyway, let's try to see something. So what you see here is 2 quadcopters which are going to fly in formation, if it helps. And it's actually in the same environment you saw the other group, Rita, talking about in the student business lab. And these guys actually have everything on board, especially the sensors, which is a student who's now at MIT doing visit. He developed the sensors. They are infrared sensors. You can see them here. So you can emit infrared, the other guy can detect, can determine from the pattern that it knows a priori the relative position and orientation of the robots, and keep formation. In fact, it can go right now in simulation up to 4. The fact is that we have 3, and we can only run 2 of the parts. The other one is being finished because it has some hardware problems. But I mean, what is really interesting, I think, is to show that this can be done with everything on board. So in this case, there's no motion capture systems, no nothing, and determining the relative position is quite hard usually, and that's why you don't see that many quadcopters flying information without any extra outside information. So that's one of the things that we did, and you can see them over there keeping a distance. I'm going to rush, I'm sorry about that. Here, I just wanted to show you. So I told you we had the Monarch project in this. So we have one of the robots in a pediatric hospital for autistic children, and I'm not showing that video. I think that's the one that will not run. But I'm showing you another project where we are now, which is with autistic children. And what we are doing is Wizard of Oz experiment, where we start having the robots partially teleoperated, or initially was completely teleoperated, but then we introduce more and more autonomy. Actually, the interfaces for the sensors and the actuators allow us to override whatever we want. And the plan is to keep overriding less and less. And we have pilot studies like this one with the autistic children in the hospital, and the robot plays games with them and speaks to them. You see the translation of what he's saying. Hi. And as we have been going through these pilots, the project is already 2.5 years, it does more and more autonomous things. Actually, the plan is also to use MDPs for decision making, and we are implementing that as we speak. So far, we have a state machine. For instance, here, the cameras that we are on the ceiling are supposed to detect this obstacle, and the robot then tells the kid that there's an obstacle in itself. And while that does not happen, we do it, of course, with a teleoperation, and we say, okay, there's an obstacle there. You should tell the kid. So again, using on the one hand our decision-making uncertainty approach, actually together with the coordinator partner, which is in SKD, which are also interested in these topics, but we were responsible for implementing everything in the robot, and this is why I showed you this. I just wanted Oscar to very quickly, Oscar, show us the simulator we are using for the robots, and then you have this two of the robots running one of the tasks of the competition. Okay? So I'm going to show you
okay. Dan is het voor een team. Pas dan ons.
By the way, there's some information on that table, and you can take some flyers if you want to know more about it. So, in fact, here and many other people, of course, across the world, we have been very excited about robot competitions for years. For instance, I've been from the early days in Global Cup in '98, and we had a team in soccer robots there. And lately, we have this team in at home, Global Cup at home. And what happens is that 4 years ago, we convinced the European Union, the European Commission, that it was important to have calls on robot competitions. And we were fortunate to be one of the two first coordination actions that run robot competitions in Europe with funding from the European Commission, Rocking, the other one was ERL-SR, led by Grisco. And then after Rocking, we started another project which started the so-called European Robotics Team. The philosophy is a little bit different. Instead of having big tournaments, we have small local tournaments, and we can have also larger ones. But this is a typical small one. With not many teams in a kind of smooth environment, so the teams can more quietly cooperate with each other and do their stuff, but still it's very competitive. If you would have been here or watching the live video, you would see that. People are a lot of adrenaline and so on. And the idea is that the teams do their points, which are different depending on the different benchmarks, on the type of benchmark. Like the atoms of the task. This part, sure you know better than me. But the idea is to benchmark these functionalities and then separately benchmark tasks which use them, which is what we are going to show you. And the different tasks, the different functionalities have also their own ranking and their own awards. So a team can come and do just object perception. They don't have to do everything. If that's your favorite topic, you can do that. Of course, we like that teams do everything, especially the tasks, because that's maybe the thing that we like most to do. On the top of it, we have, in some test beds like ours, a motion capture system, which can be used to obtain ground truth, which is fundamental for some of the functionality benchmarks. And in any case, it's always good to keep the logs of the experiments, which we can use for benchmarking later. One of the things we are interested in is to study the impacts of the performance of the things in each of the functionalities in the whole task, which is a topic which has not been so much focused on. Anyway, the tasks you will see, and there's two teams. So in fact, this finished before we were live, because some of the people, we had 5 teams. We had 1 team from Pakistan. Well, guys, can you raise your hands? Machine log from Pakistan? They're there, okay. Then there was Bart from Birmingham. Well, Bart. Yeah, there. Okay, just hi. There was another team from UK, Hearts. I can see there. They are over there. Yeah, from Bristol. And then from Germany, you'll see Rafael. That's the only guy again.
But heavily supported from soccer.
Supported, of course, by Thiago from the soccer team, which is the home team. And the soccer guys, so Oscar is one of them, and the others are over there. Okay. The first task that we will see is a task that is based on semantic network. So the robot goes around the home to store information about where the objects are in the home. There's a second stage that the teams are not doing yet, which is then to find them in the home. Actually, I think Mark is doing it. To find them in the home if we move them around. So that to make sure that they really found the objects the first time and they really have. In fact, they have to deliver a pen where they have the map with the objects. They have already a metric map that they can do before the test. So that's one of the task benchmarks. And we will show the homer team demonstrating what they can do with our robot. And then the second one will be a task on the robot navigates in the home. It has to identify given obstacles and act accordingly. And then at some point there's a person that the robot asks, okay, get in front of me and I'll follow you, and it follows the person outside of the home. So as you see, it involves perception, navigation, and so on, which are functional. And I'll stop here because we are really late and this is the part we need to show you most. So I'll let them. They already have the map. They do all the stuff with a map location. It's not one of our functionality, but you assume that it's covered. Okay? Homework.
Okay. So ready? I'm going to connect. And I will start.
Prepare a message. I am waiting for your command. I am driving to kitchen. I received an execute a message. I am driving into arena. Game started. I completed the drive to action.
Bathroom door is closed.
I scored those change. Show the other changes.
Drive to kitchen table.
You said drive to kitchen table, is it correct?
It is correct.
I am driving to kitchen _ table. I completed the drive to action. You
Turn.
said turn left, is it correct?
It is wrong.
What else can I do? You
Turn.
said turn left, is it correct? What else can I do?
It is wrong. Turn right.
You said turn right, is it correct?
It is correct. Rice is now here.
You said rice is not here, is it correct?
It is correct.
Where is rice?
Location is kitchen table.
You said location is kitchen table, is it correct?
It is correct.
Storing rice on kitchen _ table in kitchen. Please say me what to do.
Drive to coffee table.
You said drive to coffee table, is it correct?
It is correct.
I am driving to coffee _ table. I completed the drive to action. You said go ahead, is it correct?
It is
What
wrong.
else can I do? You said go ahead, is it correct?
It is
What
wrong.
else can I do?
Close is now here.
You said clock is not here, is it correct?
It is correct.
Where is clock?
Location is coffee table. Location is coffee table.
You said location is coffee table, is it correct?
It is correct.
Storing clock on coffee _ table and living _ room. Please say me what to do.
Turn left.
You said turn left, is it correct?
It is correct. Chair is now here.
You said chair is not here, is it correct?
It is correct.
Store chair and living _ room. What else can I do?
Drive to right armchair.
You said drive to right armchair, is it correct?
It is correct.
I am driving to right _ armchair. I completed the drive to action.
Pear is now here.
You said pear is not here, is it correct?
It is correct.
Where is pear?
Location is
You
right
said
arm.
go ahead, is it correct?
It is wrong.
What else can I do?
Location is right armchair.
You said location is right armchair, is it correct?
It is correct.
Storing pear on right _ armchair and living _ room. Please say me what to do. You said plant is not here, is it correct?
It is wrong.
What else can I do?
Drive to dining room.
You said drive to dining room, is it correct?
It is correct.
I am driving to dining _ room. I completed the drive to action. You said go ahead, is it correct?
It is wrong. It is wrong.
What else can I do?
Turn right.
You said turn right, is it correct?
It is correct. Plant is now here.
You said plant is not here, is it correct?
It is correct.
Floor plan to dining_room. What else can I do?
So, and what the robot does now, it learned the positions of the objects that were previously unknown, and it tries to bring it from somewhere where the location was not known to a known location before. So let's
You said
bring,
Bull is now here, is it correct?
let's bring the class somewhere here. It is wrong.
What else can I do?
Bring the class to the dining room. Bring the class to the dining table.
You said bring cloth to dining table, is it correct?
It is correct.
I am driving to cloth.
So the robot has now no arms, but it is aware of that and asks for support, hopefully.
I completed the drive to action. There is no arm attached. Please put the object to the brown box on my back. I am driving to dining_table.
It's now a delivery bot.
I completed the drive to action. There is no arm attached. Please take the object from the brown box on my back.
That was the task. Now the robot exits. Go to the exit. Drive to the exit.
You said drive to exit, is it correct?
It is correct.
Goodbye. I am driving to exit.
He's afraid of so many people.
Yeah, that's a bit shy.
Okay, while the robot leaves and the next team sets up, just a few more explanations. So in this case, there's a lot of interaction between the human and the robot, of course, as you saw. There's other tasks where this also helps. In fact, the test bed even has devices like these blinds here, some lights, which can be remotely actuated wirelessly. So the robot, if you tell the robot, please switch the light on in the living room, it will do that remotely. And everything goes through a referee box.
Drive to action. You said drive to exit, is it correct?
Everything goes through a referee box here, which not only controls that, but also is capable of checking the information that comes when it is needed, the ground truth system. And for instance, when we are doing object perception functionality, check the estimation that the robot did for the location of the objects and compare it with the ground truth. And at the same time also receive the information of the robot about the classification of the object it recognized. So that's another feature that was introduced in Rocking that we are using in ERL. And here also we have, say, the central for benchmarking where the information from the cameras come. In fact, this last task I'll show you now with the home team soccer has a lot of navigation through waypoints. You will notice that because the robot is explaining as it goes. And again, if it were checking that, we would need to store the ground truth here and compare with the waypoints, one of the functionality benchmarks with that. But I mean, when you are ready, guys, I'm done. In fact, the start is given here for the top. No? Okay. You can see that the navigation is different because the Homer original robot is a differential drive one, and this guy is omnidirectional, and it takes advantage of it. So this kind of shows you also that we are really running different software from different teams. It can move backwards, for instance, which is a distinct difference.
Tricky, man.
Oh, by the way, the marking on the top of the robot is what is used to track it by the motion capture system. All the robots
I
have all the
reached the first waypoint. Moving to waypoint 2. I reached the second waypoint. Moving to waypoint 3.
Yes, yes.
Okay, so there was some problem. Can you explain what it was?
I think it took too long to get out of the door. And so it reached the timeout of into the waypoint, and then it started skipping the waypoint. Chegou para frente. Tá bom.
Ready? Ready?
Please open the form. The form is open. Going to waypoint 1.
Sim, estou a falar baixinho, porque já estamos aqui em cima, quase a acabar, por isso é que eu telefonei já, penso que 10 minutos, 15, estaremos ali embaixo. Está bem? A gente ainda está aqui a acabar a demonstração, porque ainda temos que descer dos jogadores, mas eu acho que está bem. Want to explain why you do that, Mason?
So we're blocking one of the paths and the robot should autonomously replan another path.
I used the board this time instead of itself.
I think that also then to save some time, if you want to ask questions,
I
we will try
reached the
to
first
answer
waypoint.
some of them.
Moving to waypoint 2.
So for the navigation, is it using ultrasonics on the base or is it
It's lasers.
Okay, so
I was going to ask Luis to answer. It has a laser up front and one in the back as well. That's why you
I
can move
cannot
backwards as well.
pass to the second waypoint.
I think he's going to use vision now
So
or only
now, no. So now he's going to try to find, he has to find if it's a person, a small object or a big object, and he's moving the camera up and down, up to see if the person is in front of you. And after seeing if it's a person, he will see if it's an object, a big object or a small object. And
I
that's based,
found a big object.
based
Please
on the
help
point
me by
cloud.
removing it.
So if there's a lot of points above the point cloud, above the ground floor on the point cloud, it will see that it's a big object. If there's not many points, it's a small object.
I reached the second waypoint. Moving to waypoint 3. I reached the third waypoint. Please step in front of me so I can follow you. I am following you now. Please yell stop when we reach the final waypoint. Please come back and step in front Please come back and step in front front of me again.
Oh, he likes you there somehow.
You will find, yeah, exactly. That may happen. I was wondering.
Please come back and
Whoops. Let's say we have time for a couple of questions because I warned the bus driver already, but that should be okay. Any questions? Yes.
Motion capture is only used for ground truth?
No, it's used for ground truth in this one, but in fact we plan to use it in other things, and we have been using it already. For instance, with micro-aerial vehicles, Mason is expert on that, and he has been using it with his students.
please come back and step in front of me again.
Detect if it's a person or not. Why don't you use, for example, infrared? Because you see.
I mean, any team can use the sensors they prefer. In our case, we use RGB cameras, but I mean, they could use that or anything else. And so that's not limited. The teams can solve the problem the way they want. One thing which is distinctive here, for instance, with respect to RoboCup, where we also participate, is this idea of we repeat this several times and we take the median of the results for consistency. Meaning that on one end is nice for benchmarking, to not be repeatable. But that's kind of the trade-off we have to do.
Do you take into account the power consumption?
Right now, we don't do that in any task yet. But we could. It's a matter of putting it
in
in
robotics, is power the biggest problem. You give me power as if
Yeah, and I can do.
What other tasks do we have? In the
Well,
competition?
there's, for instance, one which we use a lot in rocking, but most of the teams solved it, so we are not using. But it's very nice to see, which is a person that, an old lady that is in this room, so that's the user story of the whole thing. She lives in this home and she needs the help of the robot to keep a good life. And say she is in bed and she asks the robot to come with a tablet. The robot comes and she speaks to the robot saying, well, please go and pick up me an object or put down the blinds or something else like that. And the robot does all these tasks and comes back and asks her if she wants more help. That's one of the tasks. Another one is there's visitors coming through the door. There's a camera here and it can identify different types of visitors like deliman, postman, the doctor, and it's different the action it takes. For instance, the doctor can enter the home because she knows him already. The other guys, the robot just receives the things or takes the element to the kitchen and that's it. And this has been done also in Rocking already. These are the current tasks. And and there's another one, which is the general purpose service robot that comes from RoboCup. We have some task shares with RoboCup, which is a robot where you can ask it to do a sequence of, say, functionalities, and that's the task. First to interpret what you want, and then the robot has to do them all. So there's kind of two levels of difficulty. But some teams can already do some stuff. Say, go to the kitchen, get me an object, and then go to the living room and take a picture.
But this is scripted. You know what you can expect. There is not much natural language variation.
There are some variations. Mason, can you help,
think
or maybe
yeah.
someone else with
I think
more?
There are two ways. So currently we are using a grammar-based speech recognition, so you need to know in advance what you are going to get. So this is offline. And we are doing this offline because internet during competitions is not reliable. But you could also use cloud services like, for example, Google. In fact, we did Google speech recognition, so you can say anything you want. And then there is some natural language understanding approaches which we are actually also using. So you train data basically.
Okay. So we have to go. Thanks a lot for your visit.
Thank
Please
you.
follow me again.
Thank you.
you are